Let's review probability quiz 2. This quiz covered independent and dependent events along with some conditional probabilities. So let's look at this first question. Find the probability of A given B. So you could have pulled up a formula sheet or referenced some notes here. This is the conditional probability formula. So you need to understand what that notation means to answer this question. So in question number 1 here, we have the probability of A given B. So if I broke that down, that's the probability of A intersect B over the probability of B, okay, given B happened. So looking at the information they gave me here, they gave me a little bit more than I needed. So what I do need is their intersection, so that's 0.2. And I need the probability of B, so 0.3. And I'm going to complete that division sentence in my calculator. And if I follow the directions to round to the nearest hundredth, I get 0.67. Number 2, the table shows a relationship between the weather and Jamie's running habits. Use the table to determine the requested probability. Your answer should be a fully reduced fraction. So let's recreate this table. So I'm going to say less than 6, more than 6. I'm going to say more than 70, less than 70. This is 10, 12, 5, and 9. All right. Okay. So again, in this table, we're not given total, so we need to find those first. So this is 15. This is 22. This should be 21. This is 14. And if we take 22 and add 14, and if we take 15 and add 21, we get a total of 36 people surveyed. All right, so question number 2 says, find the probability that Jamie ran more than 6 miles given it was more than 70 degrees. So this given statement here, given it was more than 70 degrees, I'm going here, more than 70. So 15. Out of those 15, how many run more than 6 miles? 5. And again, probabilities should be fully reduced fractions, 1/3. Question number 3. We're still using the same table. So let's see what they're asking. Given Jamie ran more than 6 miles. So more than 6 miles, that's a total of 14. More than 6 miles, that's the condition, that's the shortened population that I'm looking at. Out of those 14, what is the probability that it was less than 70 degrees? Less than 70 degrees, 9. So that's the answer to question number 3. Question number 4, we're back to a conditional probability statement. It's the probability of B given A. So now when I write this, I know that's the probability of B intersect A all over the probability of A. Again, that comes from my notes, and that comes from the EOC formula sheet. So I'm following that notation there. So let's use the information they gave us. We need the intersection, 0.25, and we need the probability of A, 0.4. Again, I'm going to complete this division in my calculator, and I get 0.0, and I get 625. But the directions say round to the nearest hundredth. Oh, whoopsies. Found my mistake here. I used the wrong probability. See, maybe that's what you did. I hope maybe you're catching your mistakes as I work on them too. So that's what's not to do. What we should have done is we should have paid close attention and found the probability of A, because that's what we wrote down here. So 0.25 divided by 0.8, that's 0.3125. Okay. But it asked us to round to the nearest hundredth. When we round to the nearest hundredth, you look at this number and you decide, do I round up or do I round down? 2 is less than 5, so we round down or we stay the same. Okay? All right. Number 5. Find the probability of flipping a coin that lands on tails and rolling a die. So when we see that word and, this word and right here, that's multiplication. Okay, we're having two events happen. Now, flipping a coin and rolling a die, those are independent events. So I have a 1 out of 2 chance that my coin lands on tails. And I have a 1 out of 4 chance that my die lands on a 4. A die has 6 sides. Oh, I have a 1 out of 6 chance, good googly moogly, because my die has 6 sides. So 1 out of 6. So this is 1 over 12. A bag has 8 green marbles, 3 blue marbles, and 9 red. What is the probability of drawing 3 marbles in a row without replacement? So there's several things we have to pay attention to here. The first being, we have all these marbles, but we need a total. We need a total amount of marbles. So 8 plus 3 is 11. 11 plus 9 is 20. So we have 20 total marbles. Then it says, what is the probability of drawing 3 red marbles in a row without replacement? That's the next key phrase there. It says without replacement. So that means I'm sticking my hand in a bag. The first time I stick my hand in a bag, I have 9 marbles out of 20 to choose from. Then I stick my hand in the bag again, okay? But I didn't put that 1 red marble back. So I have 8 marbles that are red left, and I have 19 marbles left. Then I stick my hand back in the bag, and I have 7 red left, because each time I picked a red one, I sat it down on the counter. I didn't put it back in the bag. So I have 18 total left. So I'm going to take 9 divided by 20 and multiply it by 8 divided by 19 and multiply that by 7 divided by 18. And I'm going to get, it's going to give me a decimal at first, which was fine because it said you can round to the nearest hundredth there. And if you put it as a fraction, that's 7 over 95. All right, let's look at a similar question. Let's look at number 7. So number 7, we're still talking about the same amount of marbles here. Excuse me. So we know that we have 20 marbles. Now it says with replacement. So now I'm putting these things back. So let's look at what it's asking. What is the probability of drawing 3 green? So I'm going to stick my hand in the bag. I have 8 out of 20 marbles to choose from. I look at that really shiny green marble, and then I put it back in. So if I put it back in, I still have 8 green marbles, and I still have 20 total marbles in my bag. Well, I pick another green marble. I look at it, I drop it back in the bag. That still means I have 8 marbles, and there's 20 still total. So I'm going to take 8 divided by 20, multiply by 8 divided by 20, and multiply by 8 divided by 20. So it gives me a decimal 0.064. Okay. So if I'm rounding to the hundredths, that's going to be 0.06. And if I'd like a fraction, That's 8 out of 125. Number 8. Determine the probability of rolling 3 separate dice and all of them landing on a 4. So we have 3 die. 6, 6, 6. Each of those dice are 3-sided. Okay, we see that word and, so we're multiplying, right? So determine the probability of rolling 3 separate dice and all of them landing on a 4. Well, I have a 1 out of 6 chance each time. Okay, there's only 1 4 on each of those dice. So I can just multiply 6 times 6 times 6, and I get 216. Number 9. Find the probability of the deck of cards of drawing 2 numbered cards out of the deck without replacement. So when I look at numbered cards, I'm looking at 2 through 10. Those actually have numbers on them. Okay, 2 through 10. So that is 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 numbers in one suit. Okay, well, there's 4 suits. So that's 36 number cards. Okay, so out of those 36, how many cards are in a deck total? 52. So the first time I go to pick a card, I have 36 cards to choose from out of 52. And it says here, without replacement. So I pick one of those numbers, I look at it, and I set it aside. When I set it aside, I've reduced the number of number cards I have to choose from, and I've reduced the total amount of cards in my deck. So I'm going to take 36 and divide it by 52. I'm going to multiply it by 35 divided by 51. And that equals 0.475, and it keeps going, right? If we round to the nearest hundred, that's 0.48. Or if we leave it as a fraction, that's 105 out of 221. Let's look at these questions here. Do the 2 scenarios represent an independent or dependent event? There are 12 cookies in a jar of 3 different types. Martha takes a cookie and eats it. Then Mason takes a cookie. So if you're Martha, you have 12 cookies to choose from and you eat one. Well, if I've eaten one, I've reduced the jar for Mason. So whatever I eat, or whatever Mason gets to eat, depends on what I've already eaten. So this is a dependent event. The number of cookies or the type of cookies he has left to choose from depends on what I've already eaten. That concludes the review for our probability quiz 2. I hope that answered any questions or mistakes or problems we may have missed on this quiz. If you have more questions, please feel free to reach out and ask. We're always happy to help. Happy studying!